Lesson 17.1, Task 5. Calculate probabilities. A 20-sided die has faces numbered from 1 to 20 as shown in the photo. If you roll a 20-sided die, what is the probability that you get a number that is prime and greater than 10? Let A be the event that the number rolled is prime, and let B be the event that the number rolled is greater than 10. All right, so A is going to be prime, B is going to be a number greater than 10. All right, so here, A is our prime numbers between 1 and 20. So 2, 3, 5, 7, 11, 13, 17, 19 are all prime numbers. B is all the numbers greater than 10, so 11 to 20. You can use the Venn diagram shown to represent events A and B within the sample space. The desired probability is the probability of A intersection B. Notice that A intersection B is 11, 13, 17, and 19. So remember, intersection is the part where they overlap. All right, so probability of A intersection B equals N of A intersection B over N of S, which is your sample space. So that's the entire space. So there's 4 out of 20, okay? 4 is in the intersection, and there's 20 numbers on the die. So 4 over 20 reduces to 1/5. So 1/5 of the numbers will be in the intersection of A and B. All right, so what region of the Venn diagram represents A intersection B? All right, the circle representing A, the circle representing B, the outliers of the circle representing A and B, the region where the circle representing A and B overlap. Okay, so again, this section here where they overlap, that is where we found our solution. All right, what is the probability that you roll a number that is prime and at most 10 with a 20-sided die? Write your answer as a simplified fraction. All right, so if we go back up, we're looking for a number that is prime and at most 10. So we know that these are our prime numbers. So we got 1, 2, 3, 4. This one is above 10. So we've got 4 that are prime and at most 10. So 4 out of 20 reduces to 1/5. All right, so what region of the Venn diagram represents this event? All right, so it's not region A union B complement, A intersection B complement, and B complement. All right, so what region represents this event? So we're looking for prime numbers that are less than 10. All right, so prime numbers that are less than 10 would be these numbers here. So it would be A minus or A intersection B complement. Okay, so the intersection means that's representing this part here. So this part is not here, but intersection means it has to be here and here. And the prime numbers are only in the one side. So the set of outcomes that are in A excluding the set of outcomes in B. All right, so the intersection kind of excludes this overlap area here. All right, so that is all for task 5. If you have any questions, let me know. Lesson 17.1, we're going to do some extra examples here. All right, a number cube like the one shown is rolled 30 times. The outcomes of the rolls are given in the table. Let event A be rolling a multiple of 3, and let B be rolling a number less than 5. Use the information for problems 2 and 3. All right, so we've got problems 2 and 3 here we're going to look at. So let's think about event A first. Event A is going to have the set of all numbers. So you got 1, 2, 3 showing, but this is a 6-sided die. You can see the numbers 1 through 6 here when they rolled it 30 times. So multiples of 3 would be both 3 and 6 are multiples of 3. So if we're looking for event B, so we're going to have all numbers less than 5. So 1, 2, 3, and 4 are all less than 5. All right. It says find the theoretical probability of A. All right, so the probability of A would be 2 out of 6, and 2 out of 6 equals 1/3. And you always want to reduce these as much as possible. All right, the probability of B is 4 out of 6, and that reduces to 2/3. All right, the probability of A intersection B. A intersection B means what they have in common, where they intersect. So we've got 3 and 3. So that's going to be 1/6. Even though we don't have a Venn diagram, we can still see where they overlap. All right, so we want the probability of A union B. Remember, union means you join all your assets. So A union B would be everything but 5. 5 is not included, so it'd be 5 out of 6. Because we've got 1, 2, 3, 4, 5 different distinct numbers here. All right, then we want the probability of A complement. Probability of A complement. A complement is everything not in A, so it's going to be, in this case, 2/3. It's 4 out of 6. It's whatever's in B, but 4/6 reduces to 2/3. All right, and then the probability of B complement would be what's in A, so it's going to be 1/3. So 2 out of 6 or 1/3. And you can see that probability of A and probability of B, 1/3 and 2/3, again, that will equal 1 if you add those two together. All right, so that is the theoretical probability. That's based on each of these being equally likely to occur if we are just looking for the probability. All right, now we want to do the experimental probability, which means we've rolled these 30 times, and we're going to see what actually happened when we rolled these 30 times. So if we look for the probability of A, so what's the probability of getting a 3 or a 6? So 1, 2, 3, 4, 5, 6, 7. So that would be 7 out of 30 is what actually happened. Okay, 7 out of 30. All right, the probability of getting B. All right. So the probability of B would be 1, 2, 3, or 4. So let's highlight these. So here's a 1. Here's a 1. 1. Okay, there's a 2. And a 3. And 4. All right, so it's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. All right, so B is 21 out of 30. And I know that 21 and 30 are both multiples of 3. So 3 goes into 21 7 times, and 3 goes into 30 10 times. So the probability of B is 7 out of 10. All right, now the next one says the probability of A intersection B. A intersection B, remember, is the number 3 only. So how many times do we have 3? So let's clear this. So we're going to have 1, 2, 3, 4. So this one would be 4 out of 30, which reduces to 2 over 15. So 2 over 15. All right, D part says union. So we want the union of A and B. So that's everything basically except for 5s. So let's find out how many 5s we had and then just take that away. So we've got 1, 2, 3, 4, 5, 6. So if there's 6 5s, that means there are 24 out of 30 that are not. So how can we reduce that? 24 out of 30. 6 goes into both 24 and 30. 6 goes into 24 4 times. And 6 goes into 30 5 times. So that's 4 out of 5, or 80%. All right, now this one says the probability of A complement. All right, so A complement. So everything that's in B. So 1, 2, 3, 4 would be the numbers that we are looking for. So let's highlight those again. All right, so we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So we've got 20 if I counted right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, which would reduce to 2 out of 3. All right, and the probability of B complement. B complement is going to be everything not in B. So 6. So we need 1, 2, and 5s. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 9 out of 30. Both of those are multiples of 3. 3 goes into 9 3 times. 3 goes into 30 10 times. All right, that's all for your extra examples. If you have any questions, let me know.